Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum and hello everyone. Okay, so we continue our let's solve physics problem together. Okay, so today we look at Melaka 2020 paper 3, question number 1. Okay, so a student carries out an experiment to investigate how, look at this, temperature of water, the temperature of water increases with the time of heating. So diagram 1.1 shows the setup of the apparatus for the investigation. So before the heater is switched on, the initial temperature, theta naught, of the water is measured. So diagram 1.2 shows the meniscus of the mercury column in the thermometer. Okay, now we look at the question. So this is the diagram showing that um, the apparatus set up. So we have a beaker of water, water in a beaker. Then so the heater is connected to the power supply, and there is a thermometer there. And then showing the meniscus. Okay, so 1.2 shows the meniscus of the mercury column in the thermometer. Okay. Now, a stopwatch and the heater are switched on simultaneously. Okay, so after the initial temperature is recorded, so the stopwatch and the heater are switched on simultaneously. Okay, the serentak, switch on serentak. So at the time t equal to 20 seconds, so the temperature theta of water is read on the thermometer. And then diagram 1.2 shows the meniscus of the mercury column in the thermometer. Then the procedure is repeated for the heating time t, 40 seconds, 60 seconds, 80 seconds, and 100 seconds. So the position of the meniscus of the mercury column in the thermometer are shown in diagram. Okay, you need to refer to the diagram carefully. Yeah? So we have diagram 1.3 until diagram 1.7. Okay, so this is the diagram given. So when the time is 20 seconds, alright, so you need to fill in what is the temperature and then what is the change in temperature, like that. Okay, this is already done by my student. Okay, look at the first question. So for the experiment described above, identify the manipulated responding constant variable. Then based on diagram 1.2, determine the initial temperature theta naught of water. Okay, then based on diagram 1.3 until 1.7, record the thermometer reading theta in the space provided. Okay, in the space provided above lah. And then you need to calculate delta theta for the heating time, for each heating time, using the formula of, this is an important formula. So changes in temperature means an increase in temperature is theta minus theta naught, where theta naught is your initial temperature. Okay, then need to record in the space provided. So this is 2 marks. The temperature for 1.3 until 1.7 is 1 mark. Okay, the change in temperature just now is 2 marks. And then after that, you need to tabulate your result for theta, delta theta, for all the value of t. Means that theta and delta theta for all the value of t in the space below. Alright, so means that you need to have 1, 2, 3 column. Okay, so 3 marks. Then finally you need to plot graph of okay, so you need to plot graph of delta theta against time, okay, t. Then from your graph you need to state the relationship between delta theta and t. Okay, alright, so this is already done by my student. Okay, we see how they answer the question. whether can give mark or not. Okay, now, so this is, okay, so you need to look at the initial temperature first. So based on diagram 1.2, determine the initial temperature theta naught of water. Okay, is it 25 degrees Celsius? Okay, come we check. Diagram 1.2. This is diagram 1.2. Alright, so this is diagram. Okay, need to look at the correct diagram. So this is diagram 1.2. So the reading shown is actually theta naught. Here kan? Alright, so diagram 1.2 shows the meniscus of the mercury column in the thermometer before the heater is switched on. So that is actually your theta naught. So it means that the reading here, so need to look at the meniscus. So the meniscus means you need to look at the upper part lah, okay, upper part of the curve. So means that here. Alright, so this is 20, right? 30, so it means that here will be 25. Okay, so your theta naught is 25 degree Celsius. Okay, do we need to write 25.0 or not? Okay, so in order to determine whether you need to add in decimal place or not, you look at these two scale. Okay, look at 30 and 20. What you can do will be, so just minus 30, get 2 reading, 30 minus 20. Alright, 30 minus 20, and then you look at the separation between them. How many division are there between 20 and 30? So from here we can count. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So means that divide by 10 division. So 30 minus 20 is equal to 10. Divide by 10, it will be 1. So means that no decimal place. So your reading should not have any decimal place. Okay. So if you write 25.0, okay, 25.0 for this, let's say you write 25.0 degrees Celsius, this is theta naught, let's say, this is wrong because you write wrong decimal place. Okay, it should be only 25 degree Celsius. Okay, so we look at this student answer. Betul? Yeah, this is correct. So this is 1 mark. Okay, here 1 mark. Then, okay, we look at this. Okay, record the thermometer reading theta in the space provided. Then you calculate delta theta for this diagram. Okay, for diagram 1.3 until diagram 1.7. So we record the thermometer reading and then the increase in temperature using this formula. Okay, we look at the answer. Okay, from here, starting from here, 1.3. Okay, diagram 1.3 until diagram 1.7. Okay, come we look at, can zoom in. Alright, so look at this. So diagram 1.3, okay, 30, right? So here, look at this part. So exactly at the curve, okay, upper curve. So this is 30, 31, 32, correct, degree Celsius, okay. And then here will be 30, 35, so look at this. You can put your ruler here, okay, to make sure there is no parallax error. So this is 35, 36, 37, 38, 39, okay, this is correct. Then, to determine delta theta, so the formula for delta theta just now, alright, so changes in temperature is your final temperature, which is this theta, minus the initial temperature, which is theta naught just now. Okay, your theta naught just now is 25. So means that 32 minus 25, this is the answer, 7 degrees Celsius. This is also correct. And then here, 39 minus 25, okay, so it is 14 degrees Celsius. This is also correct. Okay, we check down here. Same method. Okay, read, get the reading of the thermometer. So this is 40, 45, this is 46. All right, so this is correct. And then 46 minus 25, you get 21. Tekan calculator. And then here is 50, so get this reading. Kan? 50, 1, 2, 3, so 53. This is also correct. 53 minus 25, it is 28 degrees Celsius. So make sure all the time you write the unit. And then this one, see the reading, is it 59 ke 60? Okay, you can put your ruler. Okay, put your ruler here. Yeah, it is at 60. So this is 1 mark. And then 60 minus 25 is 35. Okay, so with this, semua betul kan? So means that this student already can get here. Okay, so the reading just now semua betul. This is 1 mark. And then here semua the minus, the change in temperature, all correct. So here will be double tick lah, means at 2 marks. Okay, so I normally give mark. My mark will be depends on the number of tick that I give. Okay, because 1 tick will be 1 mark. Okay, now, so we look at this. So for the experiment described above, yeah, paper 3, question number 1 is always like this. They will start the question A by asking you the manipulated, responding, and constant variable. So from here, yeah, what is your manipulated and responding variable? Is this correct or not? Okay, is this correct or not? The heating time, that is the manipulated variable, and then the responding variable is temperature of water. Is this correct? Okay, now, in order to get the best answer, normally, okay, for the manipulated responding variable, they are normally given in the first sentence. We check whether it is given or not. First sentence, there. You see? So a student carries out an experiment to investigate how the temperature of water increase with the time of heating. Okay. So when you see this word, okay, investigate, relationship between two variable. So this will be, okay, these two are your either manipulated and responding variable. Okay. So, but you need to how do you confirm it is the manipulated variable? Okay, you see whether it is being repeated or not. Can see here the procedure is repeated, so this is an important keyword. Repeated with heating time T. So it means that this is your manipulated variable. Okay, repeated with heating time. So your manipulated variable is the heating time T. Look at the first sentence again. Do they have that heating time? Here the same thing. So time of heating or heating time is the same thing. So it means that when this is your manipulated variable, so it means that the temperature of water increases. So this is your responding variable. Alright, so just copy this. Okay, the manipulated variable, time of heating, comma T, or the heating time T. Then the responding variable will be temperature of water increases. That will be the best answer. Okay, look at this. Alright, so heating time, betul, but it's good to write the symbol that they use, T. Alright, so this is 1 mark. Okay, make it a habit to write the symbol. The standard symbol given in the question. Just like this, they give you heating time T. Okay, use T. And then the responding variable, if you look at the first sentence just now, it is the temperature of water increase. What if you write temperature of water? Can give mark or not? Here can give mark. Okay, alright, so this one also can be given mark, but it's better to write temperature of water increase. That would be better. Follow the first sentence. Alright, temperature of water increase. So it means that this is actually the delta theta. Okay, because this is your responding variable. If you just write temperature of water, that will be theta. Not wrong, but more accurate if you write delta theta. Okay, now, okay, so here, best answer will be temperature of water increase. Okay, but like this also can be given mark. Now, what is the constant variable? Can the initial temperature of water can given as the constant variable? Can or not? Increase initial temperature of water as the constant variable. So actually here, um, you look at the question, do they have any variable that is fixed? Do they mention any variable that is fixed? Okay, so far I don't see any word saying that the anything that is fixed. Adakah? No, they did not say anything. No, right? Okay, but from this diagram, we know that the experiment is using water and then the immersion heater that is connected to the power supply and then the thermometer. So now you see, manipulated variable is time of heating. The responding variable is change in temperature, increase in temperature. Do this remind you of any formula that relate to this chapter? Do this remind you to any formula? So this one is actually Q heat equal mc theta. Alright. So this theta is the changes in temperature. Normally we put delta theta lah. Alright. So means that this is already your responding variable just now, delta theta. My delta is quite small, but you can understand, right? Alright, so this is your responding variable. Now, your manipulated variable is the time of heating. It is not in this formula. Okay, so think of another formula, another physical quantity that can relate to this Q, another formula. So Q also equal to, since we use heating, right? So means that this heat energy is actually convert from the electrical energy. So the formula for electrical energy is PT. Remember, your PT equal Q. Right? So I can substitute here P times T equal mc, changes or increase in temperature theta. Now you can see that this is your already responding variable, and then T here is the heating time. So this is your manipulated variable. So it means that your constant variable can be P, power of the heater, can be M, the mass of the water, can be also C, the specific heat capacity. Okay, so any of these three can be given 1 mark. Okay, so the power of the heater, mass of the water, or the specific heat capacity of the water, the liquid. Alright, so can we give mark to this or not? Initial temperature of water. In this case, no. Okay, this one cannot. So the answer here, constant variable, will be either the mass of the water, power of the heater, power of the immersion heater, This one is mass of water, power of the immersion heater, or the specific heat capacity of the water. Okay, but you don't write only symbol lah. You write full. Okay, tulis penuh specific heat capacity. Alright, clear? So from here, okay, so this one we already discussed just now. The initial temperature already discussed. The temperature for each of the diagram already discussed, and then the increase in temperature already also. Then you need to tabulate your data. Okay, so this student is very good. Okay, can see she tabulate the data in a very systematic table. You see now, see, tabulate your result for theta, delta theta, and T. So some student might do like this. They just follow the sequence. Tabulate your result for theta, then delta theta, then t. If you write like this is wrong in terms of the sequence. Why? Because the manipulated variable, we know already t, should be written in the first column. Okay, this one must be in the first column. And the responding variable normally will be the last column. Okay, this will be the raw data that you get from the experiment. Okay, so it should be in terms of sequence like this. Okay, time, temperature of water, and then the bukan heat capacity. So delta theta here is not heat capacity. The symbol already correct, but it is not the heat capacity. Oh, so sayang. Kan sayang, you see. Delta theta. Is it heat capacity? Does it give heat capacity? Where? Where is the heat capacity? Is it given? Let us check. Delta theta. Where is delta theta? Oh, did not mention. Did not mention. They just write like that. Calculate the value of delta theta for each heating time. Delta theta. Here also delta theta. They did not say anything, right? Okay. Alright, good that this student make mistake. Okay, so that everybody can learn from here. But here can see. Kan, they only give this sentence, this phrase, this physical quantity. Temperature of water increase. So temperature of water increase here, this is delta theta. Because final temperature minus initial temperature. Did not mention, huh? Good question. Very good question. So student will be tricked by this question. Very good. Yeah. Okay. It is not heat capacity. Okay. Now, so the marks for this is 3 marks. So the 3 marks will come from here. So the first column, all the column must have name of the physical quantity. If at least the symbol like this, T, and then theta and delta theta. So for this 1, 2, 3, that is the first tick. Okay, the first tick. Second tick will be for the unit. Okay, second, degree Celsius, degree Celsius. For all the column must have unit. So that will be the second tick. Now the reading, okay, so this is from the diagram just now. So these are all correct. And then here also transferred correctly. And then here also transferred correctly. And then they have a consistent number of decimal place. What I mean is, if no decimal place, you don't write any decimal place. Just like for this, time, the temperature, and the change in temperature, no decimal place. That will be your tick number 3. Okay. Now what happened to this? So if you write like this is quite dangerous. It depends on how strict is the marking. If they are strict, then this one might be a contradict answer where you have heat capacity here, but this is not heat capacity. This is the change in temperature. If the marking is strict, so this might not be given tick number 1. Okay, if the marking is strict. Tapi Cikgu Hayati baik hati ya, so I give mark. Alright, so this one, be careful. Alright, so I just cross this, but be careful. Alright, so in this case, I give you tick 1. Okay, alright. Tapi if it is strict, so this might not be given tick 1. Okay, clear? Now, So next one is you need to plot graph of delta theta against t. So this is the graph already titled. In SPM, normally the graph already titled like that. So delta theta against t. So make sure the first variable return, this must be your vertical axis. Okay, so delta theta. Okay, because this is your responding variable. And then the second variable mentioned against that variable, so it should be the horizontal axis. So it means that t should be in your horizontal axis. Okay, now I zoom up. Okay, we see how is the graph. Okay, can see. Maybe we look at the axis first. Alright, for the first mark, in graph, normally we will have, the graph will give you 5 marks, alright? 5 marks. Okay, the marks for graph is 5. And there will be 7 ticks in the graph. So the first tick, okay, I do like this. The first tick will be for the name of the axis. Second tick will be for the, put here name, label lah, label, okay, for the axis. And then second tick will be for the unit on both axes. Okay, and then name, what I mean by name here is the physical quantity. You can write the full physical quantity, or you can write the symbol of the physical quantity. That is the first tick. Second tick is for the unit for both axes. And then tick number 3 will be for the scale. So you need to write, you need to use uniform scale, and it should not be odd scale. Okay. Now tick number 4 and number 5 will be for the point that you transferred. If all transferred correctly, you will get double tick. If satu salah, you get only tick 4. Tick 5 tak dapat. And then tick number 6 will be for the best fit graph. Okay, best fit graph. And then tick number 7 will be for the size of your graph. Okay, normally we look at 4 times 5 square. Alright, square of 2 centimeter. Okay, size of the graph. That is the minimum size lah. Alright, if you get all the 7 tick, okay, here, katakan semua tick you get. If let's say you get all the 7 tick, okay, number of tick, so I do like this lah. Number of tick, and then the marks. If you get all 7 tick, you get 5 marks. If you get 1 tick, 1 mark. If you get 2 ticks, it will be 2 marks. Okay, in between will be 3 and 4. Okay, so if you get 5 to 6 ticks, get 4 marks. It means that to get 3 marks, okay, at least you get 3 ticks. Okay, means that 3 to 4 ticks will be 3 marks. Quite easy to get this mark. 3 marks is quite easy. Okay, try to target lah. Kalau malas sangat pun, at least try to get that 3 marks. Okay, see how. So in this case, so the first tick can give or not? Alright, so the horizontal axis time and t, okay, either one of these, either you write time or t, so that is the first, that is the name and the symbol of the physical quantity. And then the vertical axis, this one salah lagi, okay, careful, be careful. Okay, actually you write symbol only pun enough. So the symbol here, okay, cikgu just tutup mata lah. I don't want to look at this. So I don't want to look at this. I want to look at the one that is correct. Alright. Okay, so delta theta, this is correct. Okay, this is correct. And then T here is correct. So it means that you already can get the first tick. Second tick is the unit, degree Celsius. Second, both correct. So you get 2. Okay, ingat mesti both axes correct. If one correct, one wrong, it will be cross here. Now, tick number 3 is for the scale. So now you see 7 7, 14, 21, 28, 35. All right. So this is not um, an even scale. So this is what we call as odd scale. So one petak, satu petak sama dengan 7. That is odd. If satu petak sama dengan 5, satu petak sama dengan 10, that is even scale. So in this case, we don't give you tick number 3 because of the scale is odd. Now look at the horizontal axis. Horizontal axis, okay. Okay, but we look at both axes, salah satu odd scale, then we cross 3. Cross 3. So remember, odd scale means, okay, odd scale is when you use this satu petak here now. Okay, if this is the same as 3 cm atau 3 cm, 3 meter, 3 newton, okay, ataupun 7 ataupun 9 or 11 or 13, okay, or 17, okay, like that. So this is known as odd scale. Okay, remember. So if odd scale, there will be cross 3. Now what is even scale? So if this one square is equal to 1 or 2 or 5, alright, or 10, 20, 50, or tambah more zero, okay, like that. So this is known as even scale. So like this boleh dapat tick 3 for both axes. Okay. But if like this, once we see 3, 7, 9, 11, 13, 17, that is known as odd scale. Why odd scale? Because very hard for you to read. Okay, just like this. Kan? So if let's say 3, let's say one petak here equal to 3 degrees Celsius. So if let's say satu petak like that, how do you read? 0.3, right? Okay, if katakan here, then quite hard for you to get the reading. Okay, so we don't give tick 3 for that. And then tick 4 will be the point transferred correctly. So from the answer just now, so here cikgu ada, so 20, 7, 40, 14, 60, 21, and then 80, 28, 100, 35. Kat atas lah, like this lah. 27, 40, no wonder lah the student choose that scale sebab senang kan to draw, but that is already tricked by the question. Alright, don't use 7, 14, 21, 28, 35. Okay, but when in term of transferring point, semua betul, all transferred correctly, so can give tick 4, tick 5. Okay, next one, is this a best fit graph? Yes, this is a best fit graph, tick 6. And then what about the size? Is it 4 times 5? You see, 1, okay, we can count here as 1, 2, 3, 4, 5. Alright, so this petak is sampai here 5, and then naik atas 1, 2, 3, 4. So here 5, right? So means that more than 4 times 5. So this one can give tick 7. Alright? So means that you get 6 tick. 6 ticks. 6 ticks. So 6 ticks will be there 4 marks. Alright? 4 marks. Okay, 4 marks. Then what about the relationship of the graph? Here. So based on the graph, state the relationship between delta, theta, and t. Now, if you are not confident with the name just now, so just use the symbol given, because here they already give you delta, theta, t, delta, theta, t. So you don't have to use time. No need to write this. Okay, like that is enough. So delta theta also no need to write the unit, tak perlu unit here. Okay, So delta theta is directly proportional to T. That is enough. So cikgu still tutup mata for this. Alright. So don't write like that. So this is 1 mark. Okay. So how much mark for all? So I think this student get satu je salah. Only one wrong. Only miss one. 2 marks missing. See here? Okay, so this question is about 16 marks. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 10 plus 4, so 14 marks. Alright, so she get 14 out of 16 marks. Okay, well done. Good. Well done. Okay, alright. So today is 14/12/2020. Alright, good. Okay, so if you have any question, you can type in down below. Alright. Okay. Alright. Bye bye. Hopefully you can understand.